In this video, we're going to take a look at the basic rules for writing chemical names. Okay, so typically the scenario you're in, if you have to do this, is that you have a chemical formula. Here's 5 examples of chemical formulas, and you need to know the name of that chemical from the formula. In a future lesson, we'll talk about how to go backwards, like if you have the name, how to go back to the formula. But let's take a look at this. So there's a few steps you need to think through whenever you run into a chemical formula, because there are different classes of chemicals, and each type of chemical has its own set of naming rules. And you have to keep those separate in your head, or at least you have to keep them separate on your notes so that you can look it up. So the first step that you need to figure out when you're naming a chemical is it ionic or is it molecular? Okay, and remember, when I say molecular, that's the same as covalent. Okay. How do you tell? Do you remember how to tell? The key was that in an ionic compound, it's a metal donating to a nonmetal. If it's molecular, that's 2 nonmetals sharing with each other. Okay, so anything that starts with a metal is going to be ionic, and anything that is made of nothing but nonmetals, that's going to be molecular. There is one important exception, but I'm not going to cover that today, just so you know. So let's just do that for all of these 5 examples right away so that we have something to go off of right here. This compound starts with N, so we pop up a periodic table, and nitrogen is up here in the reactive nonmetals. So this is nitrogen and oxygen. That's 2 nonmetals. This is a molecular compound. Okay. CCl4 starts with C. That is carbon. Okay, carbon is also in the reactive nonmetals. And the Cl from Cl4, that's a nonmetal. It's a halogen, to be specific. So this is nonmetals sharing with each other again. This is molecular. You have to do this for every formula if you're going to do the names of them. Okay, if you don't know whether it's ionic or molecular, you got a 50-50 shot of being wrong right out of the gate. Okay, you got to know. They have different rules. This one starts with Mg. Mg is magnesium, an alkaline earth metal. This one starts with a metal. It's ionic. This one starts with Fe. Fe is a transition metal, iron. So that is also ionic because it started with a metal. And this one also starts with iron. The only difference between this one and the last one are the subscripts. Okay, great. So now we know which ones are molecular and which ones are ionic. That's how you do that. If it is ionic, okay, the next thing you need to know is the metal in front, is it a transition metal? If it is, then you're going to need these Roman numerals over here in the name, or you might need them. I'll talk about that in just a moment. So yes, Roman numeral. Otherwise, if not, then no Roman numeral. Okay, and the final rule for naming ionic compounds is actually really simple. Okay, all you got to do is, once you've decided, then we're back to the middle again. You're going to put the name of the metal right here, and you're going to end with the name of the nonmetal, but you're going to add, or you're going to change the prefix to ide, I-D-E. You just change the ending, and that's it. So I'm going to do number 3 here, because that's the easiest nonmetal example that I have. Magnesium, I'm sorry, the easiest metal ionic example that I have. Magnesium is not a transition metal, though. It's just an alkaline earth metal. So I'm not going to need to deal with the Roman numerals. Okay, and so this is what that naming looks like. I just put the name of the metal, magnesium, and then the non-metal is Br, that's bromine. Okay, but I'm going to pull out my eraser because I got to change the ending to "ide." So instead of bromine, it's going to be bromide. And that's the answer here. This MgBr2 is magnesium bromide. Okay? Notice this 2 doesn't show up anywhere in the name. In our next lesson, when we talk about how to make formulas from names, you'll see why that is, that you don't need anything in the name to indicate that 2. Okay? And this is as simple as they get. You got 2 elements. You got a metal and a non-metal. All you got to do is change the ending. Well, what about these other 2 ionics that do have a transition metal, right? Iron is a transition metal. Well, what I haven't talked about in any of my prior lessons is, why are the transition metals so special? Why do we keep skipping them? Whenever we're talking about valence electrons, we never look at the transition metals. What's the deal? Well, it turns out that transition metals, they can have different what's called oxidation states. And what an oxidation state is its charge. It's a fancy word for the charge, basically. On ptable.com, if you go up to the top and click electrons, you're going to see that at the bottom of each box, not up in the big box up here, but inside the boxes, look at all the group 1s, and you'll see there's a little number 1 down underneath the name of each element. That's telling me the oxidation state of each one of those atoms. Every one of these elements is a 1+ when it's going to donate its 1 valence electron. Beryllium, magnesium, calcium, these are all in group 2. They all have a 2+. But look at some of these transition metals. Some of them have 2 numbers under them, like cobalt has a 2 and a 3. Iron has a 2 and a 3. You see, that's why they're called transition metals. Iron can be either 2+ or 3+. They both exist. Sometimes iron will donate 2 electrons and become iron 2+. Sometimes it'll donate 3 electrons and become iron 3+. Both of those situations are stable for iron. It's happy donating either 2 or 3. Okay? And that's why it's called a transition metal. It can transition between those 2 different oxidation states. Up above, you'll see a complete list of oxidation states for each element. I want you to ignore that. We're only going to look at the ones that commonly occur in nature. These are all the oxidation states that have ever been forced upon this element. We're just going to look at the ones that are the most common. So iron can either be 2 or 3. Well, look, if I'm writing the name of a compound, right? This one is iron and sulfur. And so I could just write iron sulfide. Remember to change the ending. And then down here, this one is iron and sulfur. And I could write iron sulfide. But clearly, these names, it's not enough. I need more, because these are 2 different formulas, right? One of them has the 2 and the 3. One of them has the 2 and the 3 subscript. The other one doesn't. How can I tell the difference between those names unless I add something else? And that's what the Roman numeral is. Okay, so the Roman numeral tells us the charge on a transition metal. Now be careful, it's the charge on the transition metal, not the subscript, right? So you see this Fe2. One of the most common mistakes I see students make is they'll just throw a Roman numeral 2 in there right away, and they'll say, look, it's a 2. II, that's the Roman numeral for 2. So iron II. These Roman numeral tables here are for those of you who just don't know your Roman numerals. This is another way to write numbers. If you need a 2, you write II. Okay. Well, 2 isn't actually the charge on that iron atom. Okay? What's really going on here is a little more complicated. In fact, drawing a picture might help it become more understandable. You might have to draw a picture yourself. If you can't figure out what the charge is, you can draw a picture to figure that out. Okay? Now sulfur, we know on the periodic table, sulfur's in group 16. Each sulfur's got 6 valence electrons, right? So I'm going to go ahead and draw the full Lewis structure of this big thing. And you might be asking, well, how do I know that there are 3 sulfur atoms? That's right here. And how do I know that there's 2 iron atoms? That's right here. I'm drawing the whole formula as a picture. Now each one of these sulfurs is going to get 2 electrons because it needs 2 from the octet rule. And that leaves this middle one, which means that each iron must donate 1 to that sulfur. Now look at each iron atom. Each iron atom, each Fe, donates 3 electrons, okay, when I finish that picture. So that tells me that I was wrong. It's not iron 2 sulfide, it's iron 3 sulfide. And the Roman numeral for 3 is 3 I's in a row. How about this one? FeS. I'm going to do the picture method again. Okay, 1 iron atom, 1 sulfur atom. Sulfur, I know, has 6 valence electrons and it wants 2 more. Well, looky here, iron will donate 2. This is iron 2 sulfide. And the formula is FeS. Okay. Hope that makes sense. Now to add to the complexity, we're not actually done. I've only done the ionic side. Let's do the molecular side. If it is molecular, use prefixes. You see, ionic compounds have ions. There are charges, right? This 2 and this 3 is a charge. Well, in covalent, there's no more charges. It's sharing. Okay? Things are a little different in the covalent world. We have to use these prefixes in the name to tell people how many there are of each atom. Use prefixes for subscript values. Okay, so what I'm telling you is that these are only for covalent, right, molecular compounds. Don't use these prefixes on ionic compounds. Common mistake. Let's take a look at NO2 for an example. Should I use green? Let's switch to green. N, nitrogen. Actually, 2 things. 1, use prefixes. 2, it still has to end with IDE. Ide. Okay. So nitrogen, and that's not the ending, but the oxygen now is the ending of the compound. That's oxide. So I've done the ending, but I got to put the prefix in there, okay? Oxygen has a 2 on it. What's the prefix for 2? It's di. This is nitrogen dioxide, okay? I added that prefix to the oxide to tell people that there are 2 oxides in this compound. CCl4. C. Carbon. Cl. That's chlorine. Let's change. I'm going to leave some space for a prefix, because again, I see a number there. Change the ending. Chloride. What's the prefix for a 4? Right up here, it is tetra. So this is carbon tetrachloride. This is something that used to be in a lot of aerosol cans. It's a terrible, terrible ozone-depleting gas that has been outlawed in aerosol cans. So there's a gentle introduction for you. I know this went a little bit longer than my other videos, but this is a big topic. A little bit to know here, right? You probably feel like you can't memorize all this right away. Well, don't. Just keep this in your notes and practice with your notes in front of you for a while until it starts to sink in.